Good evening, students. I start with the class. Today will be the last class on this mechanical properties. After that, I'll be completing the portion, and from next class, I'll start solving the MCQs. Okay, from first chapter onward. So while revising the chapters, I will revise in the MCQ form so that all are used to the MCQs also. Okay. Just give me 2 minutes. Huh? Okay, let's start with the question. Previous class, we were solving problems based on modulus. So we know that there are three types of modulus. First one was the Young's modulus. The second one was bulk modulus, and the third is shear modulus. To continue with the question. This is problem number 6, I think. An aluminium wire and a steel wire of same length and same cross-sectional area are joined end to end. The composite wire is hung from a rigid support. And load is suspended from free end. If the increase in composite wire find the increase in length of each wire. There are wires of two different materials. One is of aluminum, one is of steel wire. So Y of A will be for aluminum and the Y of B will be for the steel wire, Young's modulus. Both have the same length and both have the same cross-sectional area. Okay, now we know this is the formula mgl upon pi r square delta L. Now we'll see y of A and y of B has been, for aluminum it is A and this is for B. The same length means LA will be equals to LB. Same cross sectional area means this pi r square of A will be equal to pi r square of B. Which you can assume it to be L and this will be straight away pi r square. Now they are both are hanged at a support. So definitely the same force will be acting on both of them. Their cross sectional area is also same. Their length is also same. So it will be basically the same load. MGA will be also equal to, so this is the data. Now this word composite, increase in the composite wire means the length is increasing. So increase in length. Composite means both aluminum as well as sum of both. 2.7. Okay. So now Young's modulus formula is there. So we'll write for both of them separately. So just put A everywhere. Same way. This is equation 1, suppose. So we'll divide equation 1 by 2. Then equation 2 also. So whatever is same, we will cancel. We know that this and this is same. This also is same. Length is also same. So what remains is therefore y upon yb will be, these values are already given, so we can substitute those values also, this values also of Young's modulus. Put the value of y and yb. This will be 7 into 10 raised to 11. And this will reverse. Eleven and 11 is 10. Seven by 2. which is equals to 3.5 you can, and you can take this side. This will go up, so it will be. So your aim is to find what is delta LA and delta LB. Another thing what has been given is their composite increase is 2.7. So mm it is, so either you can convert it as 3 raised to minus 3, or right now keep it that much only and then write the answer also in terms of mm. If you're not converting, keep it like this. So you just substitute instead of delta this. What is delta LB value? 3.5 times delta L is basically 1. So add both of them. So that will be 4.5. You divide it. 2.7 divided by 4.5. Or basically it is 27 divided by 45. That is 0.6. You got your delta LA, you can find the other part. So delta LA plus delta LB is equals to 2.7. So this value is 0.6 mm, because I have not converted. So delta LB will be 2.7 minus 0.6. So just minus it. 2.7 minus 0.6. It will be just 1 less than this, 0.1 mm. It was asked find the increase in length of each wire. So increase in length of wire A is this and wire B is this. It's all based on the bulk modulus. First question. So for bulk modulus, what is the formula we know? You can use the letter K. Okay, instead of this now. Y we can use K for bulk modulus. So two ways we had seen that. One is dP upon delta V upon V, or force upon area, both the ways. Then P was pressure. The question is, by how much? The pressure on 1 liter of water be changed to compress it by 0.1%. Given that bulk modulus of water is because the question is in terms of pressure, the unit they have given is pascals. So the formula definitely in terms of pressure, the change in the pressure has been asked to calculate. Bulk modulus is already given. And compress it. Compress means there's a change in the volume. Now whenever they give in terms of percentage, remember that it's always delta V upon V together. Under error and all, we had already seen this type of problems. Relative error and all. Whenever you measure in terms of percentage, it's always delta V upon V. This together, delta V upon V is 0.1%. This is nothing but 0.1 upon 100. Take this formula and substitute straight away. So K is given as 2.2 into 10 raised to 9. This formula, change in this you have to calculate. This is 0.1 upon 100. This whole thing you can take and multiply up. You can use it as 0.001 also. Two decimals. So out of this, you can use 3 of them to get it back. So this will become 1. Okay, so 2.2 into 10 raised to 6 Pascal. That will be the answer. Next question. Someone is asking something. Voice is breaking. What is asking? I'm not sure. Just message, no? Something if you're asking.
Miss, how is it 10?
Out of that 3 I used, no? Here. 3. 10 raised to 3 I multiplied here. It's like 1000 I need, no? So out of 9, if I'm taking 3 and using it to convert this, so out of 9, 3, if I take 6 will remain, no? I can split it like this. 10 raised to 3 is how much? 1000. 3 using, so that 3 decimal shift, so it will be 1. So what remains is this. Understood?
Yes, miss.
Second question. An average depth of Indian Ocean is about 3000 meters. Calculate fractional compression of water at the bottom of the ocean given bulk modulus of water 2.2 into 10 raised to 9 Newton per meter square. Okay. Now you know the formula is actually K is dP upon. This we have to calculate. Fractional means fractional compression means total volume. Delta V upon V has been asked. Now this has been given. Now this also we don't know. Pressure also we don't know. Or the other formula is what? Force upon area. So force also we don't know. Area also we don't know. First we have to try to calculate this pressure. Okay, and then only we'll be able to get this delta V upon, because only K we know, E we don't know. Only what data we know is that of the Indian Ocean it is 3000 meters. So for the this now pressure for ocean, this is the formula. We want to calculate the pressure. So that will be, this is called as the atmospheric pressure. All these values are standard values. Okay, density of water, this is gravity, acceleration due to gravity, and h is the height, rho is density. These values are standard values, fixed values. So we'll have to know these values. Sometimes they might give in the question, or you may expect you to know. The atmospheric pressure is 10 raised to 5. Density is 10 raised to 3. G is 9.8. And height is given of the ocean. So just put in here, you'll get the value of P. These are fixed values. Huh? Height, they might try to. So P will be 10 raised to 5. Or you can take it as 10 for simplification. G you take as 10. 10 raised to 3 into 10 into 3. Both will write in terms of same. See, now this is out of this 2 we'll use same power we have to keep in order to add anything. So if I'm using this will already become 10 raised to 4 and 1 of that. So 300 into 10 raised to 5. 5 I want to make the power. So there are already 3, 4 and 1 0 I'm using. So total power 5. So 300 I'm keeping here. Only we can add if the powers are same. So this will be, now take out 10 raised to 5 common. So this will be 301 into 10 raised to 5. Now use the formula and substitute. This we have to calculate. K value I'll write here. Before that, under this under bracket. K is already given. That is the bulk modulus of water. 2.2 into 10 raised to 9 is equal to 301 upon this we have to calculate. Fractional change means what is delta V upon V. So delta V upon V bring this side and this whole thing will go down. So 301 divided by 2.2. This will go up 10 raised to minus 4. This will have no unit because if both are in this volume, the units always cancels. So fractional change, there will be no unit. Because if suppose this was also centimeter cube, meter cube, both would have got cancelled. That's the answer. If you write like this also, it's correct, huh? We're shifting this side. Either you write like this or 13.68 into 10 raised to minus 3 also. Next question. A solid ball of 300 centimeter in diameter is submerged in a lake to a depth where the pressure is 10 raised to 4 kg F per meter square. Find change in the volume if bulk modulus of material find a change in the volume has been asked. Now fractional change was asked, then it would have been delta V upon. Now only straight away change in the volume has been asked. So what is delta V? Diameter is 300 centimeter. So it will be, the radius will be 150, half of that, into 10 raised to minus 2 meters. Centimeter into meters will be 10 raised to minus. Now pressure, just see this. You may come across this type. kgf per meter square. Whenever there's some force, if it was simply Newton per meter square, it would have been different. But whenever there is this, so it is under gravity, so that is not multiplied. Whenever you have Newton, you know that it is always mg, mass into this. But whenever they write, in the previous problem we had also seen, whenever there's a word F and not in Newtons, then that 9.8 is missing. So 10, so you'll have to multiply it by 9.8. Then it would become Newton per meter square. Only if it is kgf, you have to do like this. Now, volume you'll have to know. Volume formula for a ball is circle, no sphere. O by 3 pi r cube. Because this is the volume of a sphere. The ball is a sphere. So radius you know. So just put the value of radius and calculate the volume. One 50 into 10 raised to minus 2 the whole cube. Now this is, you can this simplify this other way. 10 raised to minus 2 will be 1.5 instead of or next step I'll try. No issue. So into 10 raised to minus 2 means 2 decimals shift this side. It's basically 1.5 the whole cube. 1.5 into 1.5 into 1.5. It will be 3.375. Write it on top. Here it will get cancelled. 3 ones are 3, 3 ones are 3, 3 twos are 6, 3 fives are 15. Into 4 into 3.14. Okay. So you can keep this much only as of now, or if you want you can calculate also first and then substitute. So 14.13. Now you can, so it will be k will be given as, straight away substitute. How much has been given? 10 raised to 6. Pressure is 9.8. Delta V we have to calculate. If you reverse this, V will come here. V you can substitute 14.13. Delta V will come this side. Even if you don't calculate, no, this part you can put here and then calculate. Characteristics will come. Now you multiply and write your answer. So out of this 4, 2 will go. 9.8 into 14.13 divided by 100. Meter cube. Volume will be cube. That will be on. Next one. When a metallic cube is subjected to a stress of 6 into 10 raised to 9 Newton per meter square, each side of the cube gets shortened by 1%. find volumetric strain and bulk modulus. Now stress has been given. Stress is nothing but force upon area. But now the main thing is the entire this has been shortened by 1%. So cube means obviously it's volume. Bulk modulus is always related to the volume. So last time we were talking about sphere. Now this might be cube. So that cube will shrink and become small. So now the volume here, basically bulk will be always in terms of volume. So what has been given? Each side is shortened by 1%. Find a volumetric strain and bulk modulus. So you know that bulk modulus is nothing but stress upon strain. So we know stress. You'll have to calculate the strain in order to calculate your bulk modulus. So strain is what? Change in volume, delta V upon V. If you find this, you're able to find this, you can find a bulk modulus because stress is already given. And strain is nothing but change in the volume upon V. So what is the volume of cube? L cube. Length into length into length. Because of a cuboid, it is length into breadth into height. But for cube, all the sides are equal. So that will be length into length into length. Or basically a cube or L. If one of the side is L, the sides will be L. The height also cube. Now if you see, we have to deal it with the percentage. So how we were doing for this error, same we have to do here. So this will be delta V upon V. Whenever there is a cube, the power always becomes the coefficient. So this will be delta L upon L. So if you see percentage, you just have to multiply it by 100 on both the sides. So this is nothing but the percentage change in the volume. The percentage change in volume is nothing but 3 times percentage change in length. How much has been given? The percentage change in length has been given as 1%. In the question it is given. This will be 3%. Delta L upon L has been given as 1%. So what is percentage change in volume? Nothing but delta V upon V. So now you got this. So bulk modulus is nothing but, so this is your strain. So 3% means 3 upon 100. Stress is already given in the question. -0.01 means 10 raised to -2. We take it up, it will become +2. 10 raised to 11 will be answer. Newton per meter square. That will be the answer. Next one, that will be on shear modulus. Shear modulus, you know that it is. You can use this symbol now. Okay, shear modulus will be again same thing, stress upon strain. So force upon area upon delta L upon L, or L given as theta. If length is given, you have to use this. If theta is given, you have to use this. First question, tangential force of 2.5 into 10 raised to 5 Newton is applied on surface of area 4 centimeter square, rotates it by angle of 2 degree with respect to it's also called as modulus of rigidity. I have given you. Find modulus of rigidity. Now, tangential force. Force is given. Or sometimes you might use the word shear force. Area is given as 4 centimeter square. You'll have to convert it. Centimeter will be in terms of meters. That will be 4 into 10 raised to -4 meters square. Angle is here another data has been given. Now obviously under this you cannot substitute degrees. Whenever we are dealing with numbers, suddenly you cannot divide angle by normal. This will be in terms of radians usually. So they have given already the conversion. 1 degree is equals to 0.017 45 radian. So 1 degree. So 2 degree would be 2 into that. So in terms of theta has been given. So which formula I will use? This force upon area upon theta. So this will be force is 2.5 into 10 raised to 5 upon area upon theta is 2 degree into radians would be then it just reverse. So multiply this by 8. This will be 1.396. This will go on top and become 5 plus 4, that will be 9. Divide 2.5 by 1.396. That will be 1.79 to 10 raised to 9. This one. Of 5 centimeter cube as its upper surface displaced by 0.65 centimeter by a tangential force of 0.25 Newton. Calculate modulus of rigidity. Five centimeter cube. So now this is given in terms of length and force. So you will need area. Area is not given, but you can always find a area. Whenever the force is acting on this, it will be on the face of the this, not on the whole body. might be shifting. So only one face it faces, not on the whole cube. You don't have to find a volume. You just have to find area of the face on which the force it is acting. Area of cube face. That will be 5 into 5 centimeter into 5 centimeter. That will be 5 into 10 raised to minus 2. 25 into 10 raised to minus 4 will be the area. Because this is the length of the cube side. One side is been given. So area of the face will be length into length. That will be 25 to 10 raised to minus 4. Displaced. Displaced means change in the length. L is 5. And force has been given. Now it will be this formula. Stress upon strain, force upon area, delta L upon L, because now theta is not given. You can write this as reverse. And then substitute all the values. Force is 0.25, area is 225 into 10 raised to minus 4, length is 5, and delta L change in length is, just check the unit, 0.65 centimeter. Again, this also will be in terms of now calculate. This also 5 into 10 raised to minus 2. This and this will cancel. Rest you calculate and write the answer. And unit will be Newton per meter square. Next one, just leave to one space for to write the answer. Do the last one. A metal cube has a side of 10 centimeter. One surface of cube is, surface means one face, okay? One face of the cube is to be displaced through 0.01 mm, keeping opposite side fixed. Find tangential force. N is already given. This is the modulus of rigidity. Now force we have to calculate. Same thing now. L is 10 centimeter. displaced to 0 point, displacement means delta L. Millimeter will be 10 raised to minus 3. N is given. Area we'll have to calculate. This into 2 times square, length square. Now use the same formula as the previous one. Now only force we don't know. Force upon area. This will reverse, no? Now substitute the value. So this already is given. Force we have to calculate. Length is 10 into 10 raised to minus 2. You can write it as 10 raised to minus 1 also. Area is 100 into 10 raised to minus 4. Change in this is 0.01 is nothing but 10 raised to minus 2. This value is 10 raised to minus 2. Put. Now calculate F. Everything will go this side. This thing will come down. Four point five into 10 raised to 5 minus 4 minus 3. And this 10 is 45 into 10 raised to Newton. Is the answer. With this, I complete the chapter. Next class onwards, revision on all the chapters. We'll stop here.